There's an Archive X publication that came out this week, and it's highlighted and it's called The Era of the 1-Bit LLMs. All large language models today are in 1.58 bit, so potentially a lot more energy efficient and cost efficient. So we are now talking about there will be so many evolutions on how we think about and doing this. We are so far away from an end state in any of the stuff we're doing. And here we now have, how can we make it a 1-bit approach? Could you help us, Anders?
I think you spoke about when I wasn't here for last week, but
used a little bit, but I think it's worthwhile talking with you.
What is the 1-bit approach? I didn't understand.
Yes. Yeah, okay. So basically, instead of having the traditional FP32 or 32-bit floating points, or going to FP16 that a lot of models are using in mixed mode, going to FP8, only using 8 bits in floating point, or even using 8 bits for integer mode, which is even faster than the floating points. And there are even like 4-bit integer models that are just using integers instead of floating points. Now they have a 1-bit model. And the really weird thing with this, it's not really 1-bit because it had -1, 0, or +1. These are the only 3 possible values that a single neuron can take, or synapse if you were to be correct. So the parameter can take -1, 0, 1. So if you take a log of 3, it basically it's 1.58 bits. Anyway, the really strange thing with this is that they achieve the same level of accuracy as FP16. So using only 1.58 bits, they achieve the same performance as 16-bit models. And then significantly lower amounts of memory and significantly faster from a time perspective. This is like
any negatives? Was it only positives?
I haven't seen any negatives. And one other positive thing is that when you go to this kind of -1, 0, 1, when you do a matrix multiplication, which is basically what all these kind of large models do, they multiply like a vector with another matrix, they move from actually having to do multiplications to only additions. So you can just add up the numbers, you don't need to multiply, and that significantly reduces the complexity of the computation as well. So it's significantly faster, and then achieving the same performance. It's like magic. It must be something wrong with it, but